Hello, everyone. Hiya. We're going to start things off in a couple of minutes. So if you'd like to take your seats, that would be great. Cool. So before we start off with the talks, I just want to say welcome to React London beginners. I'm sure you're all acquainted with the pizza and the drinks. I hope that kind of fills the void of what was a dismal ending to Game of Thrones last night. How many people watched it? Terrible. Terrible. I'm sure we can talk about it at the pub later on. My name is Rain. I'm a software engineer at Red Badger. For those of you that don't know, Red Badger is a digital consultancy. And we work very closely with our clients to produce some awesome user-centered products. If you're interested in finding out a little bit more about what we do, feel free to go onto our website, which is red-badger.com. We have some great talks for you lined up for tonight. We're going to start things off with John Yardley, who is from Red Badger. And he's going to let us know everything basics about React, what it is, how it works, how it differs from maybe some other stuff that you might have done in the past. Then we've got Gavin Williams from Theodo, who's going to have a little talk about keeping forms, building forms, components simple and fast with something called FormLink. And then finally, last but not least, we have Dave Williams. There's no relation. From Visoki, who's going to talk about loading data into our React components, how we can work with that with something called React Front Load. So in terms of the order of the evening, we're going to do the first two talks back to back. Each talk will be about 20 minutes to half an hour. We'll have a little Q&A session afterwards. Then we'll have a little 15-minute break where you can have another stab at the pizza and the drink. Then we'll round things off with our last talk. We've got some space booked out in the Marquee of Granby, which is a pub just down the road, where we can talk about all things Game of Thrones and all of the things. I'm sure the speakers will be there as well. So yeah, I think we can kick things off by please introducing John to the stage.
Hello. Is that working? Oh yeah, that is working. Hi, I'm John Yardley. As Rain said, he's already described what Red Badger do. I'm a technical director at Red Badger, so I don't code as much anymore, so hopefully my live coding demo won't fall on its face later on. But yeah, I'm here today to essentially talk about what React is, why it might be useful to use, and how it's differed from previous ways of building front-end web applications. Talk through some of the sort of fundamentals about component design and how you can use different types of components for managing state or for just rendering static content in a functional way. And then I'm going to try and essentially, I should give you that. And then give a demo and basically going to take you through a sort of a really boring to-do, because I have no imagination, a to-do list app, and then basically refactoring that into a bunch of stateful and stateless components and how you wire it all up together in a live demo. And then obviously any questions. And there's some other stuff about further reading and where else you can go to learn more about React. So where else better to look than the React website for a definition of what React is? And it tells us that React is a JavaScript library for building user interfaces. So I've highlighted library here because it is not a framework. It is not like Angular or Ember, where it has an opinionated way of dealing with how you fetch data from a server, how you manage your state. React is purely for focusing on the view and allows you to make all of the other decisions on your own. And there are different ways of implementing side effects, different ways of doing server-side rendering. So it gives you the freedom to do what you want and do things in different ways based on the project or product in hand. Yeah, and it's only for user interfaces. So it's a very specific set of concerns, and it does them very well. Again, from the website. Facebook tell us that React is declarative. So it is declarative in the sense that you declare your intent of your views. So rather than like saying do this, do this, do this, where in old frameworks you sort of have to outline all the different run commands, you basically describe how you want it to look, and then React sort of takes over you don't have to worry about the rendering because React does that all behind the scenes, which simplifies the way that you reason about your application. It's component-based, so everything in React is a component. So down from a button, which you might write a fundamental like atomic component, to then a form, which might be a button and a field, and that is itself a component which has two components within that. And then you also might have a higher order component, which strings all of the form elements together, which doesn't have any concern around the way that it renders those things, but it is just concerned about data flow and callbacks and actions and how that works. And finally, there's the promise of write once, run anywhere. And this is a holy grail concept that's never really been attained by anyone in the history of software engineering. But React does offer a nice abstraction from the implementation details from a lot of platforms. So things like React Native now support you can use the same code base to target iOS, Android, and the web, and TV, and watch. And you can also now do things like VR, I'm sure an AR library will come out soon. So like it is, for those of you or us in the front-end world who are using JavaScript and have become familiar with the paradigms and architectural patterns of React, you can use React to pretty much run on any platform. Okay, so who knows what MVC is? A few hands, hopefully. Okay, brilliant. That makes my life easier. As I said at the beginning, React is really only concerned with the view part of this. And it more, I don't know, go back 10 years maybe, lost track of the years. There were frameworks like Backbone and Marionette and all these sort of MVC, MV star, because MVV, and all different combinations of like architectural patterns. And React just wants to look at the view and how you render that. And it is, yeah, so it makes us think about in a functional way. So the view is the projection of our state. So if this were a function, you had a function which did something, you put your state in, you get your view out. And this is repeatable, it's deterministic. If you put in some state and you keep on running the same function, it shouldn't ever change, which means it's much better for testing, it's much more stable, you have less bugs. Whereas in the previous world with MVC, you would have a controller which would then use a whole bunch of data models to render very specific parts of the view. And then you end up having this complex mesh of like two-way binding. You'd have to really think carefully about if you were going to update your state somewhere, what bits of the application would update. And there was no real one source of truth for state unless you were sort of quite forward thinking. And basically this ended up in a massive nightmare. You'd have things removed and you get errors from not unbinding events, and then you fix one bug and it was like whack-a-mole and you get another 100 bugs, and this was not fun. This is very much not fun. Although like there were some very good implementations of this, but I think when you start to operate this on a large scale, it becomes very complicated. And so what the guys at Facebook did was they came up with this concept of the Flux architectural pattern. It's very much a unidirectional data flow. So you have an action, which is run my app, and then you have a dispatcher, which then goes and does something. Then it goes to the store, which is where your state is stored, and then renders that into a view. And then you might have a button on your view, which then you click, it sends an action to the dispatcher, which then goes to the store and then renders a view again. And so you just have this one-way data flow. And because you don't have to think of all these micro updates that you would have done previously, React does some intelligent diffing using a diffing algorithm, which means that you don't have to think about what needs to be updated on each state change. It does all of that for you on the whole. There are some exceptions to that rule. But because of that, it makes your the declaration of your views a lot simpler. So this is the diffing that goes on behind the scenes when you update your state. So you have a data model here, which is your state. So you might have, I don't know, a list of things. And if you clicked the button and it added another item to your list of things, React will compare what's in the real DOM in your browser. And then in order to, rather than just re-rendering the whole DOM, because that's quite a slow operation, it uses an in-memory DOM called the virtual DOM. It's much quicker because it doesn't have to actually paint the DOM itself. It's just in memory, it's like headless. So if you've ever used any testing frameworks like, oh crap, I forgot what it's called. you can run Chrome in headless mode, and you can do testing on the server and whatever. It's a similar thing to that. So yeah, it then does a diff between the two, and then only patches the thing it needs to, and you don't have to worry about that, which makes everything nice and simple. So another a great thing that React brought to the scene was JSX, which is an extension of the JavaScript syntax to have a more HTML-y-like way of writing your views. So it's not exactly the same as HTML, but it essentially allows you to bring those HTML type structures into your components, and you can have that the view layout logic right next to any interaction logic or any styling that you might have in one place, which again makes it much easier to reason about components than it would have previously, where you'd have a massive CSS style sheet or Sass like collection of files, and you'd have your JavaScript and you'd have a HTML, and actually trying to navigate those and make sure you change them all I found it horrible. I hated it. So JSX does look very similar to HTML. So this is just like a header 1 element. It allows you to do some JavaScript evaluation. So in the first instance, we have a function which should return 3, if my maths is correct. And so at render time, this would render the number 3. The second one, you can inject variables. So that could be a string or a number. Or object if you've done something wrong. And then the last one is just string interpolation. And so that's how you would inject values into a bunch of list items. And it also allows you to use sort of more standard HTML attributes. So if you wanted to assign a class, a style class to an element, you'd have to actually use class name, because class is a reserved word in the JSX syntax. If you want to add a method or a function to an on-click handler, you do it using the on-click prop. And what's nice about React is it standardizes events over different browsers using a synthetic events system, which actually takes a lot of the pain out. I suppose that's why jQuery was invented way back in the day, is to like cover all those things. So there's less hacking to do here. It's a standardized event implementation. And then, yeah, if you wanted to pass a variable to a URL, you do so like this. As I said, it's all about components. React is very like component first sort of way of thinking. So you can create custom components, and this is what it would look like. And if you wanted to pass data into that component, we'll talk about props a lot. Props are data going down into components. And when a prop changes, that component will re-render. So here, items might be a list of strings, and it's being passed down to the list items here. And then you can also do some nice conditional rendering as well. So in this example, we've opened up a JavaScript thing. And so if isLoading is true, then we exit early, and then we don't render anything. But if it is false, then the interpreter will fall through to the second part of the expression and load and render the loading p tag. So there's little like tips and tricks you can do like this. So components. Let's talk about components. So this you might think is a component. This is a snapshot from our website. But actually, when you think about it, there's more than one component here. So we'll have a header, we've got a form, and actually the text, the label for the image the label for the form might actually be a component on its own, and your form might be a component, and that would be wrapped in another component. So essentially you want to create really small reusable things that have as little state as possible, so that it can be reused around your code base. And then the line around the edge would be what we call a higher order component, which orchestrates the whole thing and doesn't have any concern about, or it might do, doesn't have too much concern about the view and the way that it looks. And so React gives us two types of components. So the first one is stateless functional component. I think it's that way around, which, like the slide previously, let's quick go back to that. Basically, is a function that returns a view. So, so we have a function. We get some properties, which is what you can define, and then essentially we return a a bunch of JSX, which will then go on to render some HTML. So here, in this example, we've got a H1 tag which says hello, somebody's name. And so this is a pure function. So no matter if you put the same thing in, you will always get the same result. There's no side effects in there whatsoever. If you do want to deal with side effects, then there are other ways of doing it which are coming out or have just come out in React, but I just thought I'd cover the basics today. You can use a Stateful Component, which is a class. It's a JavaScript class. And in order to be able to create one of these, you create a new class which extends from the React component class. And here you've got this render method, which is the only required method on this class, and it just returns some JSX. If you want to add some state to your class, then you create a constructor. You override the constructor of the parent component. You always want, this constructor will receive props, which come from the above component. And then you always want to call super, which basically runs the parent's constructor, which does some React internals. And then you can set your state here by this.state, and then this is an arbitrary object of whatever data you want to keep in state. And I should say state, in this context, is stuff that only changes within a particular component. So props, you want to do most things by props if possible, but then if you have a state like if you have a component like a form, which has got some state going on inside it, this is where you would use state. And then as part of the component class API, we have a method called setState, which we can pass in an object, and it will update in an asynchronous fashion the bit of state that we tell it to update, and it will override that value. And then once that's happened, React knows that there's been a state change, and then it will do a re-render of the page, but then only will update the difference between the previous render and the new render. So here, if I click on this button, it calls this.update state. Update state will call set state, so the state will update, and then it will re-render, and then we'll get the new value in the p tag. So that's a quick whistle-stop tour of the different components. So the component class itself, as I said, only requires the render method. So you could have a bunch of stateless components that you can render with these components, but there are some benefits to having a stateless functional component if you're not mutating state. There's some efficiencies that React does under the hood, I think. So if you are adding state, you need to add a constructor to add the state. And then there's these what are known as lifecycle methods. So we have component did mount. So once a component's mounted and rendered into the DOM, you can this function will get called, and inside there, for example, if you're using a JavaScript library that makes use of the canvas, and you want to be able to get the canvas element so that you can have this library render stuff, you can do that logic in here. Component did update gets called when either the props change or the state changes. So a horrible example of this would be if you wanted to make an AJAX request based on a form being updated. There are much nicer ways of doing that, but that's an example of what you could use that for. And then component will unmount is basic, as it sounds, so just before the component gets removed from the DOM, if you have any listeners to any DOM elements that you've manually added, you can remove those in there to stop any JavaScript errors occurring. And then once this is executed, the component will be removed from the DOM. Okay, so that's a really quick whistle-stop tour of, hopefully that's not too new to people. I just thought, hopefully it's valuable to some people. So I'm going to do a quick demo about how I would go about refactoring an app from just like a stateless component to giving it some state, and the way that I would componentize it. I'm going to make use of NextJS, which is a really, really nice way to run isomorphic React applications if it's not incredibly complicated. It gives you a really good starting off point because there's zero configuration to get it running. It gives you server-side rendering out of the box, which is quite nice, and it also has some really nice dev tools that come out of the box without any configurations, such as hot reloading, by where if you change one of your components, it updates it in the browser in real time, and then also keeps the application state so that you don't have to keep on playing with the forms. And so you just add it like this, yarn or npm or whatever the new GitHub thing is, add next React and React DOM, which is the renderer for the DOM, and then you can literally run yarn dev demo. Okay, so I have done a little prep for this because the talk's quite short. So just to show you, can everybody see that? Is that all right? Brilliant. So this is my package file. So in here, as you can see, I've just got Next, React, and React DOM. And then as part of the Next.js documentation, it will say, copy this script snippet in. So we've got a dev command we can run, which will basically run Next in dev mode, which gives us live reloading, hot reloading, and debugging capabilities. And then we have build, which is a production build of the application, which you can then deploy onto Heroku, AWS, Azure, if you're into Microsoft. And then, yeah, and the start command is what you would stick in your Docker file or whatever you're using to run your application. So that's literally all the configuration you need to do. It's pretty simple. And so if I'm already running here, just to show you that I'm not cheating, you're on dev, and it will start at my development server, and you can see that I didn't even press the key. I now get a to-do list, which is possibly the best bit of product design anyone has ever seen. Okay, so so I have created. So the way that Next.js works is it has a slight opinionated way of approaching things. So it has its own built-in router. So I can like go to / blah 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 blah, and I get a 404 page. And the way that I create pages is in a pages directory with the path name in there. So for example, index, you'd expect like gets run on the root. It's just one of the conventions that this framework uses. It also has nice things like normally in a React app you'd have to import React from React in every single component. It gets a bit tedious. There are ways of configuring your build to your environment to not have to need that, but in Next.js case it's also automatically imported, which saves a few key presses. So yeah, so we're going to make this thing interactive in less than 10 minutes. Okay, so yeah, this is basically just like HTML, and here I would say we've got a header, which could be reusable. We've got a form item, which allows us to add items to a list, and we've got a list, which is a rendering of the collection of items added through the input form. So I'm going to refactor this and reactify it and add some state and whatnot. So the first thing I want to do is I'm going to replace this header1 component with a header component. So here I've got essentially just a function that returns some JSX, and this will render my my header. So I'm going to change that so you can see this in the left-hand side. And what I can do here is I can import my header from my components folder, which I've created, close that tag, and then in my browser I get yard list to-do list. Now, the implementation of this isn't great because it's not reusable. It's only reusable for me. So if I was to render this on a server, actually we probably want to inject someone's name into here. So what we can do is now we can use props to make this reusable. So I can open some curly braces, which means I'm going to evaluate some JavaScript, and I can just call props.name. And then notice here, there's nothing printed now in the h1 tag, but I can now add the prop name into here and add a string, save it, and now it says John, or I can, Albert, whatever. So if you were to render, I mean, this is not for example, you might have a variable which is pulled from a server, and then we can in here, because we're evaluating some JavaScript in this prop, we're getting the value from the variable. Yeah, I can change this now, and Julian. Okay, cool. So that is that's a very simple stateless functional component. And you can actually make this a bit nicer by destructuring name out of the props object. Like so. And you still get the same thing. So now this component's reusable, and this is a really good thing you want to be thinking about when you're building your applications, trying to make things as reusable as possible. Okay, so let's move on to a list of things. How do we make a list of things? So in here, I have a stateless functional component, which is a list of things, and I'm going to stick this in here now. Oh, not that one. There we go. So my index component here wants to manage the state of what's in the list and needs the ability to be able to update that list. So in order to do that, we need to turn this into a stateful class component. So we can do that by saying class index extends react.component. The first thing you want to do is create a render function that's going to return the JSX we already had in place. So this is now running, it's exactly the same application, but now we have the ability to add some state to it. So as I showed you in the previous examples, we can create a constructor which receives some props from the upper level component, which in this case is NextJS. NextJS's router will run this with some props. We want to call the parents constructor so that React can run some internals. And then we can have this.state, so we attach state to the instance of this class, and it's going to have a value of items, which is going to be an array of strings, and we'll just stick in example item here. No, yeah, cool. So next thing you want to do is you want to pass this array of items into the list, and we do that by creating an arbitrary prop called items. And here we can access this, the instance of the class, state, and then items. Now, that won't change here because this is only static. We're not rendering anything dynamically. So in here, in our lists component, we can receive some props, and we've called them items. And within our unordered list element, if we map over those items, so we get item, we can then stick in, some JSX here. So essentially we're just going through each of the lists, getting the item out, and then injecting the item string into a list item. If I save that, now we get example item, which is from the state in the upper component. One thing to note here is that actually we've got a console error. And you will come across this many a time. Each child in list should have a unique key prop. So the key prop is used by React to basically, when you've got lists of things, to know what's been added and what's been removed and what's changed. Never use the index of the array for this, because if you are pulling out items from the array and it's changing the index ID of each item, React's going to get confused. You might get some weird behavior. So it needs to be a unique ID. So normally, if you have lists like this, you'd actually have a list of objects, each of which might have a unique identifier, which is generated from the server. So you want to use something like that, or use a compound key that's going to be unique for each item. So in here, because this is a really great app, we can just say lists item, and then we can just interpolate this string with the item name, and then our error goes away. But obviously this is going to hit a problem, because if I add another item called example item, then I'll have duplicate keys. So it's just something to think about when you're designing your applications, that you should have unique identifiers for any lists. Okay, so the next bit we want to do is we want to be able to basically make this form add an item. So I'm going to pull this out of here, and I'm going to stick that in a stateful component. So when I want this to return this JSX, and then I'm going to plug this in here. It should still work, brilliant. Okay, so we will need to add a method. So our index component is all about managing the state. in this instance. So I'm going to add a class method here called addItem, and we want this to receive a new item, which will be a string, and then we're going to use the React component class setState method to update the items array, and we can do this immutably by using the spread operator to spread the existing items in the state and then add our new item to the end of the array. So now we'll get, if we add in a new string here, we'll get the same list that we've already got with a new item at the end. And this will then cause the whole component to re-render, and if there are any changes, it'll update the DOM. So then we can pass this down as a prop. So we can pass functions down as props as well. So I'm going to add item, this.addItem. And then that method is now available to me in this form component. Now, we want to be able to get the value of this input field when I click this button. But they don't need to know about themselves. Like, we don't want these components to be coupled in any way. We want them to be separated, because that's when you get into really awkward, like, sort of when we were looking at MVC, that's when you get this two-way binding thing and it gets a bit messy. So we want to abstract the state of that out from those components. So in here, we're going to create another constructor with some state. Let's do this. Super props. And then we're going to add some state, which I'm going to call input value. And that will just be an empty string. And then what we can do is we can we need to create an updater method, so handle change. This is going to receive a synthetic event, which is basically like a normal browser event, but with some subtle differences. And then we can update the state of the component. Oh, crap. State. Okay, and then we're going to put input value equals the event.target, so that will be the input element itself, and then the value within that input element. And then we can actually plug that into the inputs on change handler here, this.handle change. So now, download the React Dev Tools for Chrome or whatever browser you're not using. If you should definitely use these. I can find my form component, which is here. See, I've got the state, and if I start to type something in here, you can see that the state's getting updated in real time. So now our state is being updated. We need to get the button, which has add item, to then add whatever's in that, the value of that text box, into the array from the higher order component. So we can do this by, so we want to do add item, and then we can call this .props. So we pass add item down as a prop. This .props add item, and we're going to pass as an argument this state input value. And the input value, add item in this context requires a string of new item. And so now, if we, I need to bind that on here. So we're going to add an on-click event, this.add item. So now if I add that, we get a new item. Okay, and another thing here is actually it's a bit annoying. That doesn't clear itself out, and any UX designer worth their money would tell you that once you click something, it should remove that. So we can actually then, we can bind the value of this input field to this .state.input value. So then, and then when we add the item, we can set state of the input value to empty string, and then by crisps. So yeah, that's like a really quick whistle-stop tour about how I personally would go around refactoring, like, sort of taking a sketch of an application and then break it down into components and then work out where the state needs to go. Cool. So Yeah, so where next? Again, like, I only had a short amount of time to get through all that. So if you're thinking about building like more delightful, bigger applications than the one I've just shown you, then definitely look into state management. The de facto thing seems to be Redux, but there are other options out there. And actually, if you've got a smaller application that doesn't require like an enormous object of state, then you might want to look at React hooks and the context API, which have just been released. They're really cool. I haven't covered styling, and there's loads of libraries and different ways you can go into styling. So yeah, style components seem to be a big thing. I personally quite like writing like React Native style JS in inline coding, inline styles, but also CSS modules are a nice bridge if you've come from a traditional HTML background and want to start getting into it without doing loads of stuff. If you want to create a multi-page application, or single-page applications with different routes, then React Router is a good one to start with, although there are other routing modules available. And then React Native is also quite cool. Like, you can write an app pretty easily, and you can even do it for VR now, and it's pretty cool. And then I'll share these slides shared around, and I'll stick the repository up on a GitHub repository. Yeah, so the React docs are really good. This one, buildwithreact.com, is a great interactive guide. Create React app is a nice way to get started if you're not building server-side applications. And then if you want a like ridiculously large list of all the things to do with React, go to this GitHub repository called Awesome React, and you can spend probably days looking at all the projects and things that people have written. Thank you. Any questions?
Okay, thank you very much, John. We're going to start our first Q&A session. So the way that's going to work, Jay's at the back of the room. He's got the microphone in his hand there. As you can see, it is a blue, square, spongy device. And what we're going to have to do, we're going to have to work together as a team to get this microphone from one person to another. So the way this is going to work is I'd hope that this will be a gentle throw in the direction of that person. And fingers crossed, we only have to clear up maybe 1 or 3 beers. So we'll see how we get on. So do we have any questions to start off with? Please raise your hand if you have one. Cool. So you get the lucky. Oh, there it is.
Testing. All right. In terms of what's your view on like the advantages and disadvantages of React? Like maybe 2 of each.
Advantages and disadvantages of React. Oh, I'm a bit biased because I really like it.
Biased is good.
I can't imagine writing UIs without React now, because I've just been doing it for so long. And I'm not saying that there aren't other options available. There are, of course. Vue's getting a lot of traction now. And there are other, yeah, I think for me, the fact that it sort of forces you down this functional way of thinking, it simplifies all of your application logic, way less bugs. So I think as long as a tool, yeah, I mean, if you're doing loads of stuff with like WebGL and stuff like that, I definitely wouldn't use React, because it's not that type of thing. If you've got an event loop going on and you've got to update a canvas or something, it actually gets a bit tricky using React, because it forces you down a way of working that's not suitable. But yeah, Vue's really good. No comment on Angular. Yeah.
Another follow-up question, just about the Next.js. Is the constructor specific to Next.js? Like, I mean, in React right now, we don't really use constructor that much often.
So yeah, the constructor now is part of the React API. So if you're creating a component and you want to add some state, it depends actually, because if you're using TypeScript, you can do this in a slightly different way, which means you don't have to create a constructor every time. I just stuck to vanilla JavaScript in this case because I wasn't sure if everybody was familiar with the TypeScript. Yeah, if you don't use TypeScript, use TypeScript. Types are really good. Or use Flow, or use something to type your code. It's like really, really important, I think, personally. But yeah, because this gets a bit repetitive. I think there are other ways of doing this as well, but this is the way I chose for this demo.
Any other questions?
Here. All right. Let me just think. So I know recently that they like released React hooks and
Yep.
the context API. would you say there's any disadvantage over using hooks versus, say, for example, stateful components at this stage?
So I really like the hooks because I really like the simplicity of writing components like this and not having all that boilerplate around it. So if you've got small bits of state, yeah, perfect. Like for that, so the form component that we showed you, like, yeah, it makes everything a lot simpler. It's easier to see. I don't know of any downsides to using hooks, to be honest. And if you, there are a few libraries as well that use hooks and context together. I think it's called Constate, which I was having a play with, and actually it's a really nice alternative to Redux if you haven't got massive application where you need to, have all your actions and stuff separately. But it's worth. I personally haven't played with it enough, but I quite like what I see, and it definitely simplifies it. Like it allows you to reason a little bit easier, and yeah, removes all that boilerplate. Like I haven't got to. Yeah, I mean, just writing this out all the time is so boring. So like anything to make my life less painful is a good thing.
Time for one more?
Up the front over here.
You mentioned that React is unopinionated and gives you the freedom to do things kind of how you want to do them.
Yeah.
Are there any common pitfalls or best practices? And if so, where's the best place to learn about those?
Okay. So yeah, I mean, it's not completely, it's opinionated in the way that it renders views, but actually, if you're going to be doing things like side effects, so going to the server and fetching some data, there are things like Redux Saga, Redux Thunk, if you're using Redux, that is, like Saga's Thunks. There's a new API which is coming out soon. I can't remember what it's called. There's a new part of the API which is coming out which allows you to deal with side effects in the same way you can use hooks. I'm sure somebody on my mind's gone blank entirely. That's the one, suspense. There we go. Yeah, I mean, so my biggest, when I first started using this, actually, I just wanted to grab a reference from what was being rendered and then do things with it. Like, don't do that. Like, let React take care of the re-rendering of stuff and change of things. Sometimes it's, if you're using an external plugin, like a jQuery plugin or something similar, you're forced to get the reference to a DOM element and then pass it into the plugin for it to work. I'd like to see a day when a lot of those jQuery libraries have been replaced with nice alternatives that plug and play nicely with React. But yeah, like if you do that, you just need to make sure that you disarm that element correctly before removing any elements so that it doesn't blow up. Yeah, there's the React docs are great, and yeah, the other. I think there's a lot of stuff about best practices in the interactive guide as well. So check those out.
Thanks.
Great. Please put your hands together for John.
Thank you very much. Cheers.
Okay, so as I said, we're going to crack on straight with the next talk. So if you'd like to welcome Gavin to the stage, please.
Yeah, oh, I don't mind, I can use this, it's fine. Cool. Hi, so my name's Gavin, and today I'm going to be talking to you about Formic. First, I'm going to give you a little bit of background about myself. I work for Theodo. We're a mobile and web development agency doing a lot of long and short-term projects, and I've been there for roughly a year. I've been using Formic for about the last 9 or 10 months, and yeah, I'm going to talk about my experience with it and why you should use it as for a form library. So first, I'm going to go over what this talk should cover, or kind of the questions that I hope to answer during this talk. So the first one is why to use Formic, why use any other library, or why do we even care about Formic? The next one is how. I'm going to go through some code demos of how to use Formic, all the different components. The benefits, hopefully you'll see some of those. I'll talk about some other things, both Redux Form and just plain React. So hopefully you'll see why why there's benefits to Formic. And the last one, I'm going to briefly talk about some of the problems we've encountered on production projects, because we've used this on several production projects by this point. So hopefully you can avoid some of the common pitfalls. So the first thing I'm going to cover is why should you improve your forms. Forms aren't the sexiest thing in the world. No one's really excited about forms, but they're used everywhere. Anytime you want to enter something, as you even saw in the demo before, you want to update something in a database, get some kind of user input, you're going to start using forms. And really, you want forms that work all the time. You don't want to be having lots of errors in your forms. You want them to be quite simple. And the other thing you want is you don't want to be having to write lots of boilerplate. You saw from the demo before, even with just a single input, with a button, you've got the handle change, you've got the submission, and having to write that every time can be quite costly, especially if you're writing really long forms. So next thing is, what are your options? To me, you've got about 3 real options nowadays. You've got Redux Form, you've got Formic, and you have just simple plain React. Plain React's really good, but the problem is you've got the boilerplate there. You've got to write things out a lot of the time. If you separate it into components, you can keep a lot of that separate, but it's still a lot to write, and certainly if you're doing separate projects, it's not that helpful. Redux Form is another really good library. It's probably the biggest library at the moment, but it does come with the overhead of using Redux, which is one of the state management tools mentioned before. Nowadays, especially with hooks, Redux isn't always necessary on a project, and a lot of people were unhappy with Redux Form. There's problems with re-rendering. Every time you change something in a form, it dispatches an action where you update Redux, which a lot of people find unnecessary and a bit of a overkill. Formic is a nice, I'd like to say, in between the two. You've got the reduction of the boilerplate of a normal React form, but you've not got the errors of Redux. So I thought I'd briefly go into, just to prove that it's a big thing. Formic started far more recently, and you can see about a year ago it was only about 50,000 downloads. It's, I think, NPM downloads, and you can see that even despite developers not working over Christmas, it's pretty much at the same point, more stars and less issues. I like to think they're a bit more responsive with Formic. So the first thing is, we basically saw this in the last demo. This is about what you can get as the most basic form. So you can see that on line 4, we've got the state, we've given it the value, which is just an empty string. On line 6, we've got this handle change event, where in the input we've set the handle change event, and all this does is, as before, use a set state to update the value, and the value of it is, the value of the input is just the value in the state. This has no kind of submission or anything like that, no reset like before, but this is about the most basic thing you can use for a component. So I'm going to throw a bit of code at you here. So this is Formic with the most basic Formic component. It doesn't look easy, but I'll run you through it. So here on line 10, we have the initial values. This is essentially your state. It's just the exact same. I've called it name as a field, and you can see again we're passing in an empty string. Most forms are going to want to have an onSubmit, so what you do when you got the onSubmit, this passes in the values, and all we're doing here is logging the values. The values is a dictionary, and we're doing values.name to get the name field. So we've got just a generic React form on line 15, where the onSubmit function, we pass in the onSubmit function from Formic with the props.handleSubmit. We then have just a native, just a normal React input on line 17. We've set the type to be a text field. We've given it the onChange, the blur, and the value. So Formic provides all these functions for you. You saw before we have to have the handle submit, the handle change, but really these are all just based on the name, and this is the first step of it, reducing the boilerplate. So you just do the props.handleSubmit, the handle change, the other one is the handle blur. So for those of you that don't know, usually when you click on a form, you call the onFocus to set that you've touch the field, and for any actions you have when you're clicking on a field. And the onBlur is the opposite of that. That's clicking away from the field, and then you may be wanting to do form validation, or you could even be wanting to reset the form there. And at the bottom, we've just got a submit button. So Formic really does everything based off of the name field. We've given it the name, and so you see the value is props.value.name. The submission, the handle change, all work based on the name field of the form. So I've gone through this, but I'm going to do a little bit of a demo of this, just so you understand this a little bit better. So hopefully you can see this. So here, I've got the exact same code as before. I've added an extra console log of the props down here, just to do it. So here's basically what we had before here. We've got the input here with a submit button. You can see I've logged here what the props that Formic is passing in is. So first, we have the values with the name, which is blank, because that's what it is at the moment. It's taking it from the initial values. We've got other things here, like the errors, whether the field's been touched or not, whether the form's submitting, and some other functions as well. So here, if I click on the field and type in a letter, you can see that the value is updated automatically using the handle change, and things like the so that's set. It's changed to be is valid true, and if I remove that, the validation is false. It's just got some default validation that every field should have a value, but this can be overwritten quite easily. That's just the basic thing from Formic. So again, if I type just something in and then submit, you can see things here, like we have the submission count that's gone up by 1. We have the field being touched. So this is the fact that I've clicked on the field and gone away from it. The field's been touched. So all of this is handled by Formic. And then with the submission, you can see down here in the console that the value's gone and been logged with the onSubmit function. Formic also passes in a lot of extra functions. So these are all the function that Formic passes in. There's a lot of extra things like handle reset and other things that are quite useful here. You don't need all this to start with, but it's just helping reduce the boilerplate of what you have to write. So next, we're going to look at how to just reduce even more of that boilerplate. The next component I want to go through is the form component. So the form component is another Formic component, and all this does is it takes you having to write this props.handle submit. It does the handle submit, and it also does the handle reset as well. So there's just a little bit of writing less code here. The next component I'm going to go through is the field component. Now this is one where you can already see that things are becoming a lot smaller and a lot less you're having to write out. So here it passes in the handle change, the handle blur, the value, and all the other functions that are needed in the field automatically. This is all based on the name still, but this is just helping to reduce the boilerplate of what you have to write with Formic. So really, this is what a real basic Formic form would look like. The submission doesn't do very much, but this is all you need. And it's already a little bit cleaner, and that can be defined quite easily in every component you have. So next thing I'm going to go through is some validation. Usually when you've got a form, you're going to want to validate the form works. So first, on line 8, you can see we've got this validation function. This is just the function that I've defined to validate here. So we've first defined a dictionary of errors, and all we're saying here is that it passes in the values from Formic, that the email is required. So it checks if the values email is there, and if it's not, what it does here is this is the string that it returns, and we display underneath if it's not being provided. The validate function for Formic can be both synchronous or asynchronous. So if you wanted to do like an Axios request and check something from the back end, this can also be done with the Formic validation function. So here we set what the validation function is for the form. We just pass this in from above. And down here we have what is quite often a general React pattern for displaying an error. So first we check here if there is an error message. So we check errors.email. We check if the form has been touched or not. Often, if a field's not required, a field's not being touched, we don't want to check it. The one thing that Formic does do is on submission, it touches all the fields to trigger the validation of all the fields. And then in here, if both these things are true, we display the error message, and if not, we don't display anything. So that's a kind of generic pattern for validation. And really, the next thing we do to simplify that is we remove the error message component. So this is what we had here before on the right. And this error message, again, this is another Formic component. It works off the name. So you pass in the name email here, and this just displays the error message underneath if there are any errors in the field. So now I'm going to go into a slightly different library. I'm going to go into something called Yup. So this is something that's another extra library add-on, but this is something that I really recommend for form validation, and has saved us a lot of time because you can do a lot of quite complicated form validation quite easily, and it's something that works natively with Formic. So here you can see at the top we've imported Yup, and so here instead of defining the validation function, you define a validation schema. So next we'll go into this validation schema. So first you define the Yup object, and then within it you define each of the fields that there are. So here we've got the email field. All we're saying here is that the field needs to be a string, and then the next thing we've said is that it has to be an email. So this is even doing a regex expression. Before we were just saying whether it's required. Yup has a lot of built-in things, and beside it, that's the error message that would show up if you haven't provided an email. We've also set the field to be required, and so if it's because you've not filled anything into the field, you'll get the error message of required. This just helps with a lot of complicated validation. I find it a lot easier to read than stepping through a function with a lot of ifs. And we can have a look at what this would look like. So I've just done the exact same thing before. We've got the email schema up here, and we have it here. So you can see here, if I click submit, you have the error message beside it saying that's a required field. And then you can see from Formic, we have the errors saying that the email is required. The isValid is also showing as false. If I just type something random in here, it's also going to say it, but it's going to say the new error message saying that it's an invalid email. And then if I put in something that's pretty much a valid email, we get no error messages, and we see is valid as true. So this is just helping to reduce all the boilerplate down even more. So this is what I was saying about. We can do some more advanced things with Yup as well. And this is just an example of that. So here we've got the basics we had before, a name field with a string is required. After that, we've got an age field. We've said, as you can probably see, that it should be a number, that the field's required, that the field has to be positive and an integer. We've got the same things as before with email. You can do it with URLs. And the other one you can do here is you can provide like a default value. So if they don't fill in the field, you can provide a default value for it as well. So that's the quick intro to Formic and Yup. The next thing is basically just a bit more why I think it's great. So one of the things which a lot of other libraries struggle with is arrays and nested objects. As you can see here, everything is done again with the name. So if you've got a nested object, all you need to do is personaldetails.name or personaldetails.age. Or if you're passing in an array and iterating over an array, you can just put this in here. So maybe not the most useful right now, but if I was iterating over this or mapping over this, this would be a really useful way of doing it. TypeScript as well. Typing was mentioned in the last thing. Formic's written in TypeScript, so it natively supports it, and you can easily import the types from there. And the last ones are React Native and React Native Web. Formic works really well with both of these things. I mean, it works completely fine with both of them, so there's no problems switching between React and React Native. So next is what problems. So this is something that a lot of form libraries face, is the fact that it's kind of just the way that the underlying HTML of checkboxes and radio buttons work. The value and the checked functions are often the other way around you'd expect from each of these. So really what you need to define if you're using checkboxes or radio buttons is that the value is actually the field name, and instead of the name, or sorry, the value is the name, and the checked bit is what the value usually is. So it's just something to watch out for, and it can really trip you up from a while if you don't know that. The next thing is styling with Blueprint. So one of the great things about Formic is that it just uses native React, React components underneath. And unfortunately, a library like Blueprint doesn't use the normal naming functions for the styling they do. They define a lot of their own things. So you're going to have to, basically all the boilerplate that's saved by just passing in the field and it passing in the handle submit function, the handle change, you're going to have to specify each one individually. Styling is usually relatively easy, though. It works really well with styled components and Material UI. And they're just releasing a 2.0, which they're specifically looking at how styled components and Material UI does their styling and making sure it works well with that. And the last one is testing. Whilst we all like testing, it's really easy to do snapshot tests with this. It's not easy to do more integration style tests or tests of testing the validation on the submission. This is because Formic does asynchronous validation. So when you're actually submitting the form, you'd have to wait for this validation to happen asynchronously and then re-render the form and check that the errors show afterwards. So that's been a quick overview of Formic. Hope that's been a little bit useful. If you want more, I've written an article a few months ago on Formic, and as well as that, we have a lot of other helpful things on the Theodo blog. So that's it. Thank you.
Okay, any questions for Gavin? Over here? Jay?
Okay. Is there any way to include error message inside of fields?
Inside of the field?
Yeah, like built in somehow, I don't know. Or do we have to care our error message component?
I mean, as in like a placeholder in the field to say that was required?
Yeah, somehow.
You could do that. Yeah, you can get the error messages of the field and you could set it to be the placeholder or something like that. That would be the way I would do that if it was inside the field, because you can define things like the placeholder for the Formic fields. It uses native React, so if you're doing it with a normal input, it would be the exact same where you define placeholder equals errors.name and do some styling on it to show it as red or something like that.
Okay, how about the drop-down selector?
A drop-down selector. So one of the great things about Formic is you can actually use your own custom components inside it. So you can use your own, you can set the field component type to be a drop-down, and you would do exactly as you would with a normal React drop-down inside that.
It means there is no any built-in field for the
No,
drop-down.
it's not. There's no like custom fields. It's not something that defines its own custom drop-down or anything like that. It is just an input, and you can define whatever type of input it is. You just set the component equal to be your custom drop-down component or custom selector component.
Okay, thank you.
Any other questions? Come on, there must be one. Ideally, like round here. This would be great. Yes, there we go. Slick.
With the yum validation, how do you handle like customizing the error messages to the different things? So for example, for like an email, you've got like is email and required. Like how do you sort of deal with like which error message you display and things like that?
So sorry, if I go back to this example here, so you can see here if the error is because we don't have the correct email, that the error message that will show is the invalid email error. Whereas if it's because the field hasn't been entered, you can say it's required. If we go back to here, you can just pass in these custom error messages into each of these. So I'll display I can display a different error message depending on like which criteria is failing essentially.
And is it like the the first one in the chain there?
Yeah, I'm pretty sure it's the first one in the chain is the one that would be the one that is displayed first. You can see here it's now number required. You could put the required at the end, but here they're saying the required error message is before the number.
Great. One more question.
Could you still use it alongside Redux? Like, could you lift that state up?
Yes, we do use it alongside Redux on most of our projects. Most of our projects do include Redux, but it's a nice way of not forcing every single thing in your form to be in the Redux state. So you could just have a wrapper around it. There's also a Formic higher order component that makes it quite easy to update the Redux state with it. But yeah, certainly if you want the values to be in the Redux state, it's quite easy. But the thing is, you don't have to have them in the Redux state.
Great. Thank you very much, Gavin.
Thanks.
Okay, so we're going to have our 10-minute break now. So please feel free to grab another drink, another slice of pizza. Toilets are just through the door on the right. And then we'll finish up with our last talk in about 10 minutes. So I'll see you then. Okay. So last but not least, if you'd like to put your hands together for Dave.
Hi, so I'm Dave. I'm from a little startup, tiny startup called Vizoki. It's actually just me and 2 other people, so it really is tiny. I'm the CTO there. Just to kind of give you a little introduction to me, I'm Dav Nick Will, that's David Nicholas Williams on Twitter. And this is my GitHub, and this React front load is the library that I'm going to be speaking about today, which it's a library that I wrote. Basically the question or the problem that the library tries to solve in React is this one. How do we do asynchronous data loading when React itself is synchronous? So before I sort of go into the problem, I just want to kind of get a bit of a gauge of the audience here, because this is like a React for Beginners meetup, and I guess beginner varies depending on who you're speaking to, the definition of that word. So I just want to sort of show of hands. Who here has dealt with server-side JavaScript like Node.js? Who knows Node.js? Okay. What about server-side rendering in React? Has anybody done that? So just a few people. Okay. I guess the last one is everybody or has anybody kind of dealt with synchronous and asynchronous? Well, asynchronous programming in JavaScript with promises. Is everybody kind of okay with that? Okay. Cool, because I'm going to do a bit of a code demo at the end, and yeah, I just want to know, how sort of fast or slow to go and what to dig in on. As I say, the problem that we have with data loading, and this is like fetching data from an API that's loaded from a database, the standard kind of thing, is that it's, obviously by nature asynchronous. So you go into the network, you have no idea when the response is going to come back. And with React, as kind of John was speaking about in his talk, it's very much synchronous. So it's like a very sort of functional paradigm. It's kind of data in as props essentially, and then a pure function runs, and then out of the other side, you get some kind of DOM representation or some markup. So there's I'm going to start with the client because it's kind of what people know and are most familiar with. And on the client in React, you've got a sort of like a state machine like model. So as I say, you've got props in. The render function happens inside the component. And then, it's sort of like, spits out some sort of like, DOM representation and renders something on the page. But then, because you're in the browser and you're on the client, it just kind of like lives there forever. So it's kind of like a state machine. It's just kind of sitting there. And when those props kind of update, as you can see here, it's going to render again. And then it's going to, it's another pure function acting on different input. It's going to spit out a different output. But you've got basically this kind of infinite loop of updates of props that can happen, and re-renders and re-renders and re-renders. And how does this kind of relate to sort of asynchronous, data loading? Well, it actually lends itself quite well to, asynchronous programming because the render itself is synchronous, but the props updating can be as asynchronous as you like. So, the render can happen. In the background, there can be some sort of like loading going on. And then as soon as the new data kind of comes in, you just update the props and you re-render, right? On the server, though, it's a little bit different because on the server side, when you run, a server render in React DOM, the React DOM server library, It's just a pure function. So you basically, it's the same sort of basic concept. You know, you have your JSX, whatever that might be with your component. You take in some props into that JSX, and you have an output. But in the case of the server render, the output is just like a string of markup, usually. It's a string of markup. And then you're just done, and you send that markup to the browser, and that's it. The component doesn't live forever. It's not like sitting there, like waiting for new props, updates to props. It's just like it exists for those few milliseconds, and then it's gone. And then the next request comes in, and a new component is spun up and stuff like that. So this is problematic when it comes to asynchronous data loading, of course, because this ideally you want this to happen in as few milliseconds as possible. You want your obviously renders to be as fast as possible. It is synchronous. There's simply no time to there's no opportunity in this to actually do any like waiting around for data. It's a synchronous function. So this kind of is the root of the sort of problem. And the problem is that data loading kind of fundamentally has to work differently on client and server. As I said, on the client, it's kind of simple. When the component renders, you just like kick off the data loader, probably in like a lifecycle function, something like that. When it loads, you just update the props and you re-render the data. It's simple. On the server, the only way that you can kind of replicate that behavior is by sort of like knowing what components are going to be rendered inside your view, and essentially loading the data that those components will need kind of ahead of time. And then, you can do that part sort of asynchronously because the request itself is asynchronous on the server. But only then, once the data is loaded, can you run this this synchronous render function. So you have to kind of load the data in first. So basically, you can't. You have to know ahead of time what you're going to load, and this is problematic. And what I'm going to do now is just show a. If I can just. Cool. Can we see this? Yeah. So I'm going to show basically an example application to kind of illustrate this problem a little bit better. And then I'm going to kind of show how this library that I wrote, React Front Load, tries to sort of solve this problem. So here I've got like a super simple application. It's just like, you can imagine like a blog. It has 3 different articles. And when I load it, it's not going to load because the server's not started. Okay. So yeah, it just like loads the data from an API. This data is just coming from an API, and it just renders the components like that. So let me show you the actual React. The component here. So the component that we're really interested in is like this, this box which displays a blog post. It's here. It's called blog post, and kind of as I alluded to earlier, what we're doing here on the client is, first of all, we render this markup, which is just some divs with like a title and some text. And then what we do is when the component mounts, just using this lifecycle hook, we just fetch from this API, API blog post with whatever ID the blog post happens to have. And then we just basically load this data into like a global store. So this thing is just like some naive kind of like copy of Redux that I've just written for this app. Usually you'd use something like Redux, but the point I'm trying to make here is that you don't need Redux for this. This could apply equally to like Redux, MobX, any state management solution. It doesn't matter. The concepts and the problems are the same. So as I say, we render. When the component mounts, we do the fetches, and the data sort of loads in. Okay, so the question is, how do we make this work with server rendering? So I'll go to the server now. Can you see this, by the way? I forgot to check if the... Yeah, is that okay? Sure. I'll just maybe make it a bit bigger. So yeah, this is the server side. So basically, if I just sort of go down here, this is the function from the React DOM server package, which is called render to string, which is the function provided by React to do server rendering essentially. So as you can see here, I just pass in app, which is the just the JSX I was just showing you. All it does is instead of like rendering this to the DOM like in the client, it renders it to a string, which I've called markup here. And then we just do a second step here, which is basically, you need to take this markup and you need to actually inject it into like a full HTML document. So here I've got this. It's just like really simple, just a title, a body with, you probably recognize this. It's just like the root element of the React application. And this is just like the bundle script. This here is where we inject the server rendered markup. So this is how server rendering in React works. Basically, all you do is you take the root element, the same as you have on the client side, and you just inside of it render the server rendered markup, which, just to say again, has come from this function, render to string. And then on the client side, I'll go to the client now. Basically, you just use this hydrate function from React DOM. This is kind of similar to render, which you might have seen if you've not used server rendering. You probably use render instead of hydrate. Hydrate's kind of just like the server rendering version of render, and all it does is it takes the same root element that you usually do, renders the application markup into it, but it's kind of smart enough to understand that the root element already contains server rendered markup, and it basically knows how to synchronize the two, so it won't like do the work again, it won't do the work twice if this produces the same markup that was already rendered on the server. So that's just to explain what's going on there. So if I go back to the app code, the actual page here just consists of these like 3 blog posts. So I'll just add like another one here. And this is just coming from like a dummy API that I've implemented in the back end. I changed something there, yeah. And I'll just reload the page just to, let me just need to actually run the build. Cool. Just restart the server as well. So yeah, you can see there's now like 4 blog posts. So just so we understand what's going on here. So the question is, how do we make the data loading that is happening here work on the server? Well, as I said in the introduction, the kind of like standard way to do this is basically just to guess, not really guess, but know ahead of time what exactly we need to load. And what do we need to load? Well, we need to load these 4 blog posts, right? Because they're what's in the page. So if I go back to the server, you'll see I've just commented this out, which is going to make it work. So what I'm doing is I'm just populating my store. Again, this could be like a Redux store, whatever, with some like initial state. And this is where I, basically, guess or preload what I know is going to be like rendered by the application. So you can see here that I've got, blog posts 1 to 3 loading on the server. And so what I'm going to do is I'll restart the server just to run this code. And I'll just hit refresh. And you'll see what happens now, which is all of blog posts 1 to 3 are now server rendered, but blog post 4 isn't. Hopefully that's not too quick. You can see what's going on there. So the reason for that is that we've preloaded 1 to 3 on the server. It's in the initial store. It gets rendered into the application here, and we're not loading blog post 4. So that one just gets server rendered with like this loading indicator, and yeah, then the client side kind of loading kicks in. So this is just like an illustration of the type of bug that you can see when you have to manage kind of data loading in 2 places, because you can see that I made this change on the client here. Well, sorry, I made this change in the application here. And because I haven't actually updated this like server rendering data loading function, which has to somehow magically know that I'm expecting to render blog post 4, it doesn't work. So you get this kind of weird UX problem where like some things are loaded and some things aren't. And you can probably imagine in like a real application when you've got like not a simple page like this, but tens, maybe hundreds of different components. The problem of how to sort of like synchronize what's loaded inside in your views and what data to load becomes like really, really complicated really quickly, and it basically just becomes like a huge mess. So I basically encountered this problem quite a lot in my own applications, and I started to sort of wonder, what if instead of kind of having a hook like component did mount, we could kind of have a hook that's called something like, I don't know, async load data or something like that inside of React itself that would just kind of work on the client and server. I was like, why doesn't this exist? And essentially, the answer is going back to what I was saying at the start, which is React is synchronous. It's like a fundamental limitation of React. There is some discussion going on. I don't want to go too deep into this, but there is some discussion going on about maybe making it asynchronous in the future. React Suspense is kind of one like iteration of these sorts of ideas. But as of today, right now, it's synchronous. So it just simply, it cannot support this at all. So this just isn't going to work. So what I did was built this library, which is called React Front Load, which is essentially like a monkey patch of this. So it's like a like a polyfill of this feature. So what I'm going to do is, just because we're quite short on time, I'm just going to basically switch branch here, and I'll just show you what this code looks like using React Front Load instead of the component did mount hook. So what did I call this branch? Just reset this stuff. Okay, cool. Everything running? No. Okay, let's check that works. Yep. Okay. So. This is what it looks like. So remember this logic here in the previous example was inside the Lifecycle Methods component did mount. Well, now it's kind of pulled out into this function, which is called front load, which is asynchronous. So this is a promise So you can see I'm just returning a promise, but you know that this is basically an asynchronous function. I could kind of just do this just to kind of really make the point that it is asynchronous. And the way that basically this is connected to the React component is with this higher order component from the library called FrontLoad Connect. So that's kind of how you basically inject this kind of polyfill asynchronous lifecycle method into the component. It's just as simple as adding one line with a higher order component. There's a couple more things that you have to do. The first is you need to wrap the whole application with a provider. So this is very similar to something like Redux. Works in exactly the same way. It's just you can see here the application is just wrapped in this front load provider, and this basically just kind of injects all the guts that make the library do its thing, kind of under the hood, context and everything like that. And there's one final thing, which is you may have sort of thought, how does this work when the server render function itself is synchronous? Like that needs to be asynchronous as well, and that's absolutely right. The way that's done is by this third function, which is like basically the third and final integration point of this library, which is called frontload server render. And all this does is this line here, render to string application. This is literally the same line of code that I had before. It's just a synchronous line of code. I just wrap it with this inside a function, right? So this is like an asynchronous function, and it takes as an argument a function which returns like a server rendered output. I don't have time to go into why. I wish I did, but for now, just suffice it to say, this makes the server render, which is synchronous, asynchronous. It makes it work under the hood. So you can see now that the markup is returned like asynchronously, and the rest of the code is like exactly the same. And you can see this load data function here is now just unused. So this previous complexity is just like completely gone. It's been replaced by this one-liner, which just wraps ordinary server render logic. And so let me just do this again. Just refresh the page. Now let's just see kind of how this solves the previous problem I was talking about, which is what happens when. So I'm like a front-end developer. I come in to this project. I have to say, well, I have to introduce like 2 more blog posts to the front page. Well, now all I have to do is just do that, and this is kind of really important, I feel, in like React, because I feel like it's the React way. I think it was John again who mentioned this before, but it's that React is like very declarative. So with a React application, I always feel what you have here in this declarative markup inside your JSX should just be a description of what you want, and it should just work. And that's what this library React front load brings, is that it does just work. If I just restart the server now, you'll see that it just works. So there's no kind of updating server logic because I've updated this client logic. It's just declarative, and the data loading function itself is declarative. It just describes which data the component itself needs. The component uses that data, and that's it. You're done. So it's all kind of like inlined and declarative like that. And yeah, that's basically it. That's what the library does, and that's kind of the problem it solves. And yeah, I hope that, if you do come to sort of do server render and you run into these types of problems, that you sort of like consider this pattern at least, and maybe even the library as a solution to that problem. So I'll just bring up the final slide, which just has, again, just like the link to the repo on GitHub, React Front Load. It's also on npm, of course, and also the this code that I've shown you in this demo just now is in another repo there on my GitHub. It's just React Front Load Demo, so you can go in and like play around with that and see that server rendering logic again, and try and understand what's going on if you're not so familiar with that stuff. Thanks very much.
Thank you very much, Dave. Any questions? 5 seconds. 2 seconds. Sweet. Thank you very much.
All right.
Okay, so I just want to say a big thank you to all of our speakers. So we had John, Gavin, and Dave, and also a big thank you to Facebook for letting us host the event here. So a round of applause. So this is not just the only event that we actually host at Red Badger. We host a variety of other events, from mobile development to product strategy to our other more traditional React meetup where we cover a few more advanced topics. So if you are interested in keeping up to date with all the events that we put on at Red Badger, please feel free to go to our website at red-badger.com and sign up to our mailing list. Also, please let us know how you found the event today by using our hashtag #ReactLondon, one word, in any social media posts that you put up tonight. Just a little reminder that we're going to the pub, which is the Marquee of Granby, which is about a 3-minute walk. It's not far away, so I hope to see you there. And finally, big thank you to you guys for turning up tonight, and I hope to see you at some future events. So big thank you.